Morning, everybody. I can hear me. Can everybody else hear me? Good. I recommend moving forward then. Can anybody not see this? Same answer. I recommend moving forwards. Sorry? I'm not expecting you to read the blue. Just the white bits. That's why it's blue. But yeah, there's going to be some demos, and you're probably going to miss out if you can't at least vaguely see what I'm doing. Yeah, I decided it was time for a change. I had the silly red for like 8 years or something, so not quite sure where this is going yet. It's definitely silly though. Yes. Okay, I'm going to get started. Thanks for making it, everybody, to start with. I appreciate it's early in the morning. It's early in the morning for me, too. I really didn't particularly want to be here this morning. But anyway, I'm going to talk about, well, something I've been working on. I mean, not this particular thing, but I've been working around in this area for the last 2 or 3 years. So yeah, I'm going to talk about, well, the problems I've been solving and what I've ended up doing as like a generic solution to a load of the problems that I've had. But I'll kind of start with, well, who am I? I mean, I guess quite a lot of you recognize me. I write Perl and stuff. This talk is sponsored by, well, several people. All of these people have in some way paid me to write this stuff, or paid me to work on this stuff and release it, or paid my plane flight, or etc. They're all awesome. State 51 is, well, London-based, but we're hiring. Tim Group is in Boston, and we're hiring. So if anyone wants a job in Boston, come and talk to me. Right, so let's actually get started. This talk is about my new library, which is called Message Passing. But I guess before I'm going to tell you about the library, I should kind of tell you why, because, I mean, I wrote some code, and I never liked doing that. No, I mean, I'm a maintenance programmer, and if you're a maintenance programmer, then you can always make other people's software better, but if you write your own software, you end up 5 years later going, oh, why did I do this? Because you have to live with your own mistakes. So, okay, well, I'm not going to try and tell you the big why. Let's start with a specific problem that I actually wanted to solve. So the generic thing that I'm going to talk about in the later part of the talk kind of grew out of this, but this kind of problem illustrates all the things that I was thinking about fairly well. So, and yeah, everybody likes a story, right? Okay, so once upon a time, I was looking after those hundreds of machines that I was talking about, and I had 2 monitors full of X terms, all tailing log files all at once, and you know, this was ridiculous, really, really ridiculous. And I don't know if anyone's seen a product called Splunk. We had got that, spun a copy of it up, played with it. It was amazing. It was also amazingly costly, so it wasn't actually going to work for us. So I was kind of, you know, looking for a solution for this, and I found this thing. I don't know if anybody recognizes this project. Can we have a quick show of hands? A couple of you? Okay. So logstash, it's a project that what it does is centralized logging. So, well, I don't know. I think why you might want some centralized logging if you've got a large production environment is kind of fairly obvious. But I mean, I specifically say syslog is awful. Syslog is absolutely awful. it's UDP or it's TCP, but it's just rubbish. And you've got a priority field and severity field and a text field. And so there's no structure to the actual message. So if you want to actually cram some interesting information into your message, your log message, you have to basically smash it down into a text line, which is not so cool. And also, I love this phrase, RFC 3164, which is the canonical reference to syslog, starts, this is the observed behavior of a syslog protocol. That's not a good place. That's not a good place at all. So, as I was kind of saying, we want to do some structured app logging. I've got a Perl application, and so I want to be able to log a load of structured kind of metrics and performance data out of it. Cool. So, for example, an HTTP request. If I've got a Catalyst or a Dancer app or whatever, and I want to log a load of information about those requests. So, maybe something like this. Just as an example. So, okay, cool. So we want structured app logging. There are a load of things that are just going to write to log files that you can't control, can't do anything about. So, okay, well that's fine. We can kind of tail those files as they get written out, and use grep or regular expressions or whatever, and pass those to until we've got some structure back. So that they're much more useful. If you take your Apache access logs, then just using that as a line of text is not so useful. But if you split it back into its constituent fields, then you have got something useful. Okay, yeah. So. Just like to say that the thing that I hate most about log formats is that every single person seems to invent their own date format. I mean, can we please either use epoch seconds or ISO 8601 strings and don't do anything different? Pet hate that. Okay, so what we're going to do is we're going to take these structured logs and publish them as JSON. And that might sound crazy to you, but doesn't sound crazy to me. I mean, JSON's really fast, really, really, really fast. And obviously it's great for arbitrary structured data. Cool, okay, so we're going to publish it to a message queue. Wow, that's a piece of complexity right there. How can I possibly justify that? Well, the reason I can justify that is that it flattens load spikes. So, if your logs are bursty, you're going to log at your peak rate 1,000 times faster than you log at kind of quiescent times, and that means that if you have to actually process the logs as they come in, you need hardware that can be 1,000 times faster than your average. And well, why would you do that? So a message queue can help you smooth out those periods. It's also really good to scale, and it allows you to do quite a few smart things. So, for example, you can take severe errors and also send them to a text message, for example. You can consume part of the message stream, or that's the idea anyway. And they're also pretty good as a common integration point. I mean, most languages have some libraries for some message queues, so if you want to go between Ruby and Perl, or Ruby and Java, or Perl and Java, or whatever, having a messaging system is actually quite a good way to get that abstraction. Okay, so we have our logs, we have them structured, we've got them going to a message queue. What am I going to do now? Okay, so Elasticsearch. I don't know who's heard of Elasticsearch. Somewhat more of you than have heard of logstash. So Elasticsearch, well, it's a search engine, and it's also kind of a document store. And it does free text search really well. But it's also pretty good at other things. So you can just spin this up, and it has sharding and replication. So as your data volume grows and as you need to scale, you can just basically add more boxes, which is pretty good. And yeah, it does histograms. So I'm just going to explain that a little. So you can not just use it for text search, but you can put arbitrary numeric data into this thing and ask it arbitrary questions back, and it'll give you back aggregate metrics or counts or sums or standard deviations. It'll do all that sort of thing from an arbitrary data set for you. And I mean, this is really powerful. It means that you can just log stuff from your application, and you can come back later and ask questions you hadn't even thought of asking in advance. And I mean, if you want to keep tracking this as a metric, then sure, you probably want to be making an RRD of it eventually. But it is great for thinking, oh, I thought something that might be interesting. Should we record it? Well, no, just go and ask Elasticsearch, and it'll tell you if the answer's any use and if you should bother recording in the future. So anyway, going back to the plot, there's this cute woody guy, and he's called Logstash, and it's a project in JRuby by a really smart guy called Jordan Sissel, and it basically implements this kind of strategy that I've just outlined, and it's pretty cool, and I, got it and had a play with it, and I mean, there's a whole community here. This is like a third-party web viewer for the Logstash stuff. It's not the one that's shipped in the project. So there's there's a whole community of people around this patching it. And yeah, I mean, this is kind of some actual logs from my environment, and you can see there's a little histogram of the count of log messages and all that stuff. And you can see like here all of my things like memcache hits and etc. all broken out, and you can kind of type search questions into here, like find me all the requests that took more than 30 seconds, that did less than 2 database queries between this date and this date. And it'll give you those back and give you a histogram and all that stuff. It's pretty cool. So, okay, here's a diagram of what this is kind of going to look like. So I'm just kind of simply showing a couple of servers and their Apache logs, and they're going to the message broker, and Logstash is well, reading those Apache logs and sending them to the message broker, and then you have a second copy of Logstash that reads them from the message broker and stuffs them into the elasticsearch cluster. Okay, cool. And so the way that Logstash organizes this is you have an input stage and a filter stage, or one or more filter stages, and an output stage. So the filter stage is the thing that does your kind of Apache log parsing. You read in your raw lines, and then the filter stage is doing the parsing. And this is kind of quite interesting because it means that, well, we can do the filtering here at this stage, i.e. this Logstash is going to be running like in a central location, or we could do it here. So do the filtering on the end nodes, and it lets you be flexible with that architecture, which is pretty cool. So yeah, I downloaded this, I had a play with it, and I was pretty impressed. And then I kind of started stepping up to actually push this out into my production environment, and I kind of realized that we might have a little bit of a problem here, because I don't have that much memory. I don't have that much spare memory anyway, not for shipping logs on my web servers. Yeah, no, like seriously, dude, this is not cool. I'd like to say at this point that I mean, it does work really well as advertised. It's pretty awesome. And the JVM gives and it takes away. So when I did some basic timings, it turns out that one of the most expensive things is parsing AMQP. And if you use C Ruby, like MRI, it's about a third slower than Perl. Doing it in pure Perl is a third faster. Same code in JRuby, third faster again. So Java whips our ass. Ruby's way slower than Perl, unless it's JRuby. Interesting. So anyway, cool. Logstash on each host, that's a non-starter. I can't spend 2 gig of memory, or I can't even spend 400 megs. That's just unreasonable. Sorry. But yeah, like I was saying, I mean, I've already got these dedicated big Elasticsearch servers, so running like the central instance will be fine. Okay, cool. And yeah, it's already got all this Apache log parsing stuff and a million other parsers that I don't want to have to write the regexes for. If I can avoid writing regexes there and use someone else's that already have tests, that would be really good. Okay, so anybody want to ask some questions now before I get into actual specifics? Go.
So your goal is still to go to Logstash?
Yeah.
Okay.
Yeah. So this talks about my new library. The clue about what it does is fairly in the name, I hope. And hopefully it's really simple. It is for production use, even though it's really simple. So I'm going to kind of tell you about what I wrote and how it solves this problem. But hang on, wait a second. I'm already logging stuff from my application. Why am I doing anything kind of this complex? I mean, I could just push logs straight from my application. That'd be cool, right? And so I did that, and yeah, I didn't have a good week. I didn't have a good couple of weeks because my Rabbit server got sick, and then all my web servers burnt, and it was just generally a bad time. So I decided that yeah, logging to AMQP directly from my Perl app was completely a bad idea. One of my worst bad ideas recently, in fact. So 0MQ, hurrah! I don't know who's seen 0MQ, but I really, really, really like it. So it has all these nice properties, or at least you can configure the properties for it. But if you use these pub subsockets, you can set them up so they're never blocking. So if everything's going wrong, I'd rather that my web servers stay up and throw all their logs away, always. There's never any point where taking stuff down because you can't log is appropriate. Never. So yeah, 0MQ is pretty good, and I mean it nicely solved with 0MQ and JSON. You've nicely solved all the problems of syslog, and you've got the same sort of one. Well, same sort of much more reliable transport because again, you've got a queue there. So if your log collector goes down for say 2 seconds and comes back up, and that's fine because you'll just have buffered a few messages at the client app and it's all good. And the really, really, really big thing for Perl, and for most dynamic languages actually, is that 0MQ uses a completely different POSIX thread. So your Perl interpreter knows nothing about it, which means that all the networking just literally happens in the background. So you don't have to do it. You can just send a message and it's fire and forget, and you don't have to do anything special. You don't have to call an event loop. You don't have to make any other changes in your normal Perl code to be able to asynchronously ship messages. And that's really good, especially if you've got pre-existing Perl code. So cool. We've got a plan of some sort. We're going to have an on-host log collector, and it's going to have a 0MQ subsocket, and our app's going to publish to that, and it's going to have a syslog listener as well. And so we're just going to use the rsyslog that we've already got on the host to forward all the logs to this. And in a few cases, we're going to run tail f and tail some logs, and then we're going to push them all into AMQP. So here's a diagram of what's now going to go on. This is kind of a new plan. So this bit here is the bit that I'm talking about writing. And I mean, this could be my code, or it could be Ruby logstash. I've got an implementation of it in Perl just because I wanted to have a go. But I'm using real logstash in production. So anyway, this is where it all goes wrong, or all goes right, depending on what your opinion is. Yeah. Damn. Well. But no, actually, I mean, I did start by writing a script, and I wrote a second script, and when I got to a fifth script that was like doing stuff with different message queues, I went, this is silly. Stop doing this. I should be writing something. So let's keep things simple. Let's say that we've got an event, and the thing we'll call an event is just a hash, okay? And we're going to send it between things. And I'm going to steal all of logstash's terms here, or at least when it's appropriate to steal them, because then the terminology is nicely the same. And we'll have a thing called an output, and an output is something that has a method called consume that takes one parameter. And then we can have an input, and an input is something that has an attribute called output2. Okay, cool. And a filter does both of those things. So that basically means the only API you need to know about in the entire framework is that. That's all we're going to do. All we're going to do. So there we go. We've got an input and some filters and an output. Entire framework. No, really, that's it. Well, I might be lying because, depending on what your inputs and outputs are, they're all different. They all have their own complexity. But I've tried to do a load of work to kind of unify them so that, if it's got a host name, it's called host name. If it's got a password, it's called password, rather than the million different APIs, some which call them host and some of which call it host name. And then I've tried to make it kind of all the same in the API that I present, so you can configure these things the same. So yeah, I wrote this little library that has it's like 3 Moose roles that implement output and input and filter, and then I wrote some adapters. So all of these already exist. 0MQ, AMQP, Stomp, Redis PubSub, syslog. Someone's writing a MongoDB output already for me, and yeah, a couple of others. And so, I also wrote a DSL because I was writing these scripts that were tossing messages around, and I wanted to make this really, really easy. And so it also ships a command line application. And I mean, this just sets up something really simple for you. You have one input, one output, and you can optionally add a filter. And that's pretty useful just for testing. So the command line application looks like this. And actually, I've added two terms. I've added encoder and decoder. And encoders and decoders, they're just filters. So you input something. By default, will JSON decode it? I mean, you can totally pluggably use that YAML or whatever else you want instead. We'll then filter it, and by default, this filter does nothing. It's a no-op. And then we'll re-encode it, and then we'll output it. OK, cool. Questions? Yo.
I just wanted to give a shout out to our syslog.
RSysLog's RSysLog's UDP transport has all the problems.
It's not a reliable.
Yes, and its reconnections are shit. If your server goes down, it probably won't reconnect for 5 minutes, and you'll toss 5 minutes logs away. Oh, okay. I mean, no, I'm using rsyslog on my local host, the forward syslog, but my experience of trying to run it across like a larger network are just kind of pain and misery. So, I mean, maybe I'm doing it wrong, or maybe also it's been quite a while since. Okay, cool. But I mean, that's cool. That's nice to know. But syslog's still got all the problems of not being structured. You know, you're still basically passing lines of text about. You know, with a severity and a priority field, and I mean that's just not useful to me. Okay, so okay, I've got some. Yeah, go. Mm-hmm. Yeah, no, you totally could if you wanted to. I mean, you could build a decoder and an encoder that gzip stuff after JSON encoding it and decoding it. I mean, I haven't done that, but I think it will be about 3 lines of code. If you bother me after this, I'll write it and ship it later. No, I mean, it's that easy. Right, so, yeah, 24 meg. Well, I used Moose, and MST keeps telling me that his move thing is going to be able to like cross classes with Moose, and I keep trying it and keep breaking it. But as soon as I stop breaking it, I'm going to use MST's move thing instead, and I expect that 24 meg to drop significantly. But still, I mean, it's mostly in the I don't care portion. The thing I care about more is that obviously Moose gives me an excess depth, which means that I can't make a single file script, which kind of sucks. So I'd like to get away from that, but I haven't got that. Okay, so anyway, I think it's kind of demo time. Who wants to see a really dumb demo? Right, so this is the simplest possible demo that we could go for. So I'm going to run this, and then I can give it a hi, yapc, and it's going to echo that. And so what that's done is it's taken that from std, it's decoded it into a hash, it's done exactly nothing to it, it's re-encoded it as JSON, and it's output it syslog. No, output it std out even. Not very interesting, but it's okay. There's some more demos which might be more interesting, and they might not. Okay, cool. So let me give you an example that's more than one script. So we'll do this. We'll do something kind of almost equally dumb, but we'll pass the message over 0mq. Right, that's done. That's dead, and one 0mq. Sub, and if I do that, yeah, cool. Okay, took a second to connect, but there we have 0mq. And notably, if I go back to the diagram, the messaging direction and the kind of TCP connection direction can be completely different. You know, you can have the client connecting to the server, but the message is going that way. And so that demo that I just showed was the subscriber connecting to the publisher. But, I mean, we can do this the other way around. Have the publisher, no, example, yeah, thank you. Pub. Huh? Sorry, you need to be louder than that. Okay. So yeah, that's really interesting. I agree. You know, shipping empty hashes across the network. I should probably show you the source code to these. Shit. So these look something like that. I mean, I'll show you a publisher as well. Okay, so that's, I mean, that's shipping stuff across the network, and that's kind of literally all you need to build a log aggregator right there in those like 2 one-liners. Okay, so cool. But I mean, yeah, sure, I've got some examples in a terminal. Yeah, it does actually work. I mean, this is actually really serious. Some of the adapters aren't quite so good at the moment. I mean, like the Redis one, I just wrote because I could. I've never actually tried using Redis in Anger, so if it'll explode on you in Anger, the ones that I'm actually, kind of using work well, and a load of the others coming along. I have to say, I mean, like I said, this is really simple. It's significantly dumber than logstash, so you only get 1 thread. So if you have a really high message volume, then it's not going to parallelize at all. Whereas like the Ruby logstash totally will. It'll use multiple cores and stuff. But I mean, for me, this isn't a problem. 0MQ is insanely, ridiculously fast. Like I can ship tens and tens and tens of thousands of messages between every second between 2 processes on like this little laptop, including the JSON encoding and decoding, which is pretty good. And yeah, it does actually work, and other people are using this in production. And so, I mean, I've just stolen some IRC logs from yesterday here. So, yeah, and there's a couple of people like already writing adapters. So anyway, what about logstash? And yeah, like you kind of just asked, I'm going to use both, or I am using both. And so I have some stuff to take messages, and I'm using like Mosaic storage and log message structured, but I have a really fairly simple filter that just smashes the hash up a bit to make it look like a message produced by logstash, and then you can feed it into elasticsearch and it kind of just works. Okay, so cool. This is kind of fairly useful for logging, but also, I mean, there's a crap load of other things that you could use this for. An absolute crap load. So, I mean, I actually kind of have code that does all these things. I like the bottom one, actually, HTTP push type notifications. So this is really good for APIs, to stop people polling. I mean, PayPal IPN is a good example. The Shopify one is the best one to look at if you want to steal something like this, because they've got some really nice documentation. But basically, the message that I send is just like that. It's just a URL and some data, and then I have a component that receives that and makes an HTTP post that contains that data to that URL. And that's it, basically. Okay, so I've got all these adapters, and this means that we can actually do like loads of different messaging patterns. So there's all the things that any of these adapters support is pretty much available to you, because all of the setup for this is just in the config and the wiring. So you can have pub sub, so I publish and one message goes to each subscriber, or we can have round robin, so I publish a message and it goes to one, and then the next message goes to the next, and etc. You can do stuff with, like I was saying, with partial subscriptions. Okay, so cool. I think it's demo time again. These demos do get gradually more interesting. Okay, that one is done. Oh, that one's done. And I've got the wrong demo. A example in. Right, so this is pub sub, which means that's example out. So if I stick something into my inputs, then this should come out on both of the outputs. And there we go. It's come out on both the outputs. Wasn't that fun?
Show the code.
Sorry?
Code.
Oh, thank you. Example in. Yeah, so I happen to be using Stomp for this one, just because I can. I wanted to show you like some of all the adapters. So that's the inputs. Try tab, it helps. And that's the output. They're similarly simple. Okay, cool. So that's pub sub, and I just happen to have used Stomp. I could have used any of the other things as well. I'm using Rabbit as the stomp server here, but that's only because I mean it works with Apache ActiveMQ as well, but I can do both my AMQP and my stomp with Rabbit, and that's like it means I only have 2 message queuing servers to run, and I get 3 protocols, and so it's easier for a demo. Yeah, I couldn't be bothered spinning up like ActiveMQ as well. That was just being silly. Okay, cool. So let's do the same thing, but with round robin. Cat example in. I'm going to use ZeroMQ for this one. Example out. Okay, cool. I run that. Example out. And another copy of example out. And then if I send a message, then it goes to exactly one of those. And if I send a different message, and it hates me clearly. Hey, that got one. There we go. You know, it's basically round robin. It's not necessarily going to be completely fair, but it's totally good enough. Okay, so that was all pretty dull, actually, as far as demos go. Sorry about that. Right, so I was thinking about this, and I was thinking, okay, all these demos are pretty weak, pretty dull. So let's see what we can do. Who knows this game? Yeah, cool. Right, so let's do that. Okay. Yeah, I mean, I could and should have added more, but this is already ridiculous enough. So excuse me while I like run 3 or 4 scripts, but then we're going to send a message through like 3 message queues at once, just because I can. So, okay, let's see the source code first. Star. There we go. So we have instd in, out stomp, in stomp, out Redis, in Redis, out AMQP, in AMQP, out stood out. Cool. 1, 2, 3, 4. And there we go. 3 message queues, just like that. Okay, cool. So, yeah, I mean, I quite like this. But, right, almost got a laugh, almost, but still not there, really. I mean, come on, for demos. So, I guess, how can I top this? Well, okay, let's do something really, really, really daft. Who's heard of Mongrel 2? Okay, so let's reinvent that really badly, just because that's going to be funny, right? So who's heard of PSGI? Okay, cool. Who knows what a PSGI environment is, right? Yeah, okay, vaguely. So your PSGI environment is just a hash, you know, and we can push hashes over a network, right? So, yeah, if you do a bit of fiddling about, you can totally serialize a PSGI request as JSON. And the PSGI response is just an array, so you know obviously we can serialize that. Let's just ignore streaming responses as too complicated because we're doing this badly, we already said. Okay, so here's my example. I'm going to have a Mongrel 2 server, and then I'm going to connect a handler to that, and we'll use that round-robin distribution so I can have multiple handlers, and the multiple handlers connect to the front-end server, and they get round-robin requests between them. In each request contains inside it the serialized PSGI environment and like a reply field. So the handler then actually dispatches that against the PSGI application, gets the response, connects to the thing it was asked to connect to respond backwards, sends the response back, and that goes back to the browser. So cool. Let's try that then. Okay, kill Jenga, and so I show you my server. Okay, that's my server. And I wrote the most complicated PSGI app I could think of just to demo this. And here's my handler. Okay, so I mean, I'm basically just using Plaque up. Well, yeah, I have a Plaque app at one side, and this is my server, and this does the serialization stuff. And then down here, I have a specific Plaque handler that I run against PSGI. Okay, so server. Oops. Handler, and I need a browser. Quack. Okay, cool. That works. And, I said we were going to ignore streaming responses. Well, actually, I made those work too. So, just to show that, I've got a Catalyst app. And Catalyst only speaks streaming response. And I can run handler, and there we go, I've got the Catalyst app. And I can find my mouse. Okay. Cool. Got a Catalyst app. Yeah, and there we go. Works just like normal. Okay. Well, that's it. I really couldn't think of any sillier demos than that. I'm sorry if that was disappointing. Okay. Cool. Questions? Yo. There's no such thing as reliable message delivery. I mean, whenever you have a messaging solution, you're going to lose messages somewhere, somehow. Even if it's completely durable and you have transactions and you're committing, at some point you're going to have a server set on fire and the messages it had on disk, even if it's committing them to disk, go away. So you're always going to lose some messages. But I mean, the answer is I'm deliberately setting 0MQ in up to throw messages away in my stuff. You can explicitly unconfigure those options. So rather than throwing messages away, it'll block. But I mean, yeah, and in an MQP, you can ask for the message to be durable, and you cut your maximum message rate by a factor of 10, but your messages are on disk, so if your server crashes, and RabbitMQ will cluster stuff. It'll cluster, so you can have a fairly reliable system. If I approximately go back to my diagram, one of my diagrams. Sorry? I guess, I mean, there are some cases, but I can't think of them right now. I mean, I'm always happy with, and I always try and architect and design for the fact that we're going to throw messages away at some point. And I mean, that means that you need to kind of keep state in a database or something so that you can regenerate messages that got thrown away, or you have to kind of just deal with the fact that they're gone. But I mean, one of the really smart things that one of my directors said to me like a couple of years ago when I was just thinking about this stuff, he's like, Tom, our billing system is shit. If we could bill for everything we could think of to bill, but we only have 90% of everybody's activity, that would be much better. If we throw away 10% of our revenue, but we can bill everything because we've got a system that's more flexible, then we win. And kind of that's the philosophy I've been thinking through this stuff with. Mm-hmm. Yeah, okay, fair enough. No, I don't, there are plenty of environments where these compromises are not appropriate. Yeah, exactly. No, I mean, if you're taking people's credit card numbers and taking people's credit card numbers, and your messaging is like part of a workflow for taking people's credit card numbers, then you probably want your web servers to burn rather than not log. You know, it would be better to stop serving pages than take people's credit card numbers and throw them away. So yeah, sure, there are plenty of examples, but well, I don't pass credit card numbers across message queuing because that's yeah. I know. I entirely use syslog for credit card numbers. Any more questions? Yep. No, that's a good question, and the answer is not so well at the moment. However, yesterday I added, the day before, I added the generic concept of having an error output. So, I mean, you have everything as before, but every single component gets an error output, and so if anything goes wrong, that component can trap an exception, and send the exceptions somewhere off to the side, which, I mean, could quite possibly just loop back into itself and get logged. I mean, you can do whatever you like with that. But yeah, no, there's initial support for being able to nicely handle everything going wrong and get logs from that. I mean, that's one of the big things that I need to work on some more. Nope. Nope. Absolutely not. Sorry? Sorry, there's a question about benchmarking?
Oh, I just said that could be a good way
Okay. Yeah, it probably would be. You know, I mean, one of the other things that I would like to do that I haven't done yet is have a set of filters that just kind of count aggregate stats. So then talking about the error or info channel that I was talking about before, you'd have something in the middle which would then every 10 seconds emit a message saying that we're processing 10,000 messages a second or something. And I mean, that would be dead easy to do. I just haven't got there yet. No. No, explicitly not at all. You can totally do that sort of thing. I mean, the only example I've actually got in the distribution of that at the moment is there's a filter which delays messages for n seconds. You know, so you send a message in and it only comes out 10 seconds later, and that's like 10 lines of code or something. But yeah, doing something to get counts and stats would be, you can do exactly that. The next step is to find a new maintainer for it, clearly. No, I mean, being serious, I want to add a load more queues. I want people to try reading the documentation, because I have actually written documentation for this, but I need to be told why it sucks. And so I guess the next step is getting it to a point where people can just find a distribution on CPAN and pick it up and go. And I mean, I'm hoping it's not that far off. Certainly, I showed a slide with one of the guys that I know. I used to work with. He seems to have picked it up and be running with it. So I can't be that far away. But no, the more adapters, and more handling exceptional conditions, and yeah, things like stuff that should just be in core, like message counts, and better filters and etc. I'm using, well, I've got code that does the indexing myself, but I'm also using logstash. So kind of amusingly, my indexer here, I have a logstash running that does all the parsing, but I actually have my own code doing the indexing into elasticsearch, which is mostly for, well, historical reasons, and B, kind of failover, because what I actually do here is I split the log stream, and every one of my log messages has a UUID, and so I just insert everything into Elasticsearch twice, which means that if one of the boxes falls over, nothing notices. And you know, Elasticsearch, because everything's got a UUID, dedupes stuff. So it means that I have got this, when I've got RabbitMQ there, I've also got a Rabbit cluster. So it actually means that while I'm saying I can throw messages away, this is a pretty bloody reliable solution, actually. You know, I can lose one of my message brokers, I can lose one of the Elasticsearch servers, I can lose one of the indexers, whatever can go away, and I still have my entire message stream. Yep.
What would you say your production is?
Up to about 25 million messages a day, and that is using about 20% of one core on a 2.7 gig machine that's 4 years old. Yeah, so I don't actually know how, I haven't done any timings for how many messages you could push through it, because it's bloody fast enough for me, totally fast enough for me. So, you know, by orders of magnitude, it's fast enough. I mean, everything that's logged in any way from hundreds of hosts, not a problem. Anyone else? Okay, I think that's it. Thanks a lot, everybody.